discuss is computer architecture. So, the first thing is the CPU. What is CPU? CPU is the central processing unit, means where all your processing is done, just like our human brain that controls our functionality of the body, who coordinates and maintain and manage the complete system of our body. Similarly, the CPU is known as the brain of the computer. So what is the purpose of CPU here? It consists of different subcomponents. So mainly the CPU coordinates and manages all the other functions of our computer system. So we have different parts of CPU. We have control unit, we have arithmetical logical unit. So what does the control unit do? It will direct the operations of the processor, means it will control all the operations, just like a manager who dictate other employees what they have to do and how they have to do. So similarly, you can say that the control unit works as the manager for the processor. It will controls all the functionality of the system, what a specific part is doing, how they have to do, what they have to achieve. So this is all that is done by the control unit. Then the second thing is the arithmetic and logical unit. So what does it do? It will perform the arithmetic and logical operation. Now, what are the arithmetic operations? Means it can be your basic maths operation like addition, multiplication, division, subtraction. And what are the logical operations? So it can be the greater than comparison operators. Means logical operations can be done that contain some logic, like you want to compare two values, whether it is greater than, less than. So this is what the arithmetic and logical unit will do. Then we have caches and registers. So if you remember in the last lecture, we have discussed about caches and register. So I told you that the cache is a very smallest, the registers are very small and fastest storage that is inside the CPU. Means the most frequent documents are placed in registers. That's why they are faster, because anything or any data that CPU needs, the register can provide them directly. Then after that, we have caches. Now, cache is a very high speed memory. So it is no doubt built outside the processor, but it will provide you the high speed memory. It can be used for data, for frequently used data and instructions. Then we have the other thing, that is the fetch execute cycle. So the CPU execute instruction in the form of cycle. Like now, first one will be the fetch, then we have the decode, then we have the execute. Now in the fetch, the instruction is retrieved from the memory. Fetch means that you will get the instructions from the memory. Decode means that instructions are going to determine to perform a specific operation. Means they have set to do a specific operation. Then the execute means that function is going to be performed or implemented. And all of these three processes work in a cycle, one after one, until all the execution of CPU is done. So this is the fetch execute cycle. Then after that, we have low level and high level language. Means we have two types of languages in computer system. Now, what is the difference between these two languages? Low-level languages are the type of languages that are closer to computer but far from humans. Means we humans cannot directly understand these low-level languages. Why? I told you that in the last lecture, the computer only understands the language of zeros and ones. It cannot directly understand the coding languages or any other. It only understands the zeros and ones. So that is the low level language. That is easily understandable by the computers, but the humans cannot directly understand. Now in low level languages, we have two types. We have machine code and we have the assembly code. So what is machine code? Means the binary instructions that you directly execute in the form of zeros and ones. Then we have the assembly language. Means now this is also in the human readable form. that we call mnemonics. Means you can say that if we want to move instruction A to B, then we use move A comma B. So that is the assembly language. Then we have the high level languages. Now, high level languages are easier for humans because we can easily write and understand what is written in that. Like for example, we have Python, we have Java, we have Ruby, we have Rust, we have C or C++. Now, Python is these are all the different languages in which we write our code. And then with the help of the compiler, the compiler or the interpreter will convert that code into the machine code that can be directly understandable by the computer. So we have all of these different languages. No doubt we have many more there, but these are the main languages that are used. So Python is a high level language. Why it is used? Because its syntax is very easy. It can be easily interpreted. Now other languages are compiler based, but the Python is the interpreted language. Means what is the difference between the compiler and interpreter? What they are, we will discuss that later. Then we have Java. These are all the different languages in which we used to write our code. So after that, we have translators. So translator, as I told you that the computer only understands the language of zeros and ones. Means the machine code is understandable by the computer. So what these translators will do, they will convert the code of high level language into the low level language. Now, what are the high level languages? As I told you, the languages that are closer to humans but far from computers. So, what these translators will do? These translators will translate the code into machine code, the high level code into machine code, and then it can be directly understandable by the computers. So, the first type of translator is the compiler. Now, what does the compiler will do? It will compile or translate the code as a whole. Like it will take the complete paragraph like this. It will check for specific errors. Like it will compile the complete code in the machine code, like in the language of zeros and ones, zeros and ones. So that is a compiler. Means a type of translator that will compile or translate the complete code at once. Then we have interpreter. So what does the interpreter will do? Interpreter will translate the code line by line. Like first of all, it will take this line and convert into zeros and ones. If it contains the error, it will send a notification to the user that there is an error, you have to remove it. Just like if you remember in Google Colab, we use the Python. Python is the interpreted language, interpreter-based language. Like we write a specific code, and then when we click on the cell having the run button like this, it interpret the code and give us the output. So that was the interpreter because it was translating the code line by line. That's why we say that the Python is the interpreter-based languages. Then we have the assembler. So you know that I told you in the low-level language, we have also another language that is the assembly language. Now, assembly language is also a low-level language, but the difference between the machine language, machine code, and assembly language is that so it uses mnemonics. It is like a human readable form. Like you can it can be easily read by the human. So that is the assembly language, and the assembler is used to translate that language. So if I draw a specific flow diagram for that, is that this is our main code that is written in the high level language. Like here is the code in the high level language. Then after that, here we have a compiler or we have an interpreter. So it depends what you use, whether you are using a compiler or an interpreter. After that, we have a assembler. Assembler is used to convert the code of assembly language into machine code. Then after assembler, at the end, we have the object code, or you can say that the machine code. That is in the form of zeros and ones that we get after translating the source code to the object code. So we have two types of code. The code that is written in the high level language, like C++, Java, or other, is known as the source code. And the code that we get after the conversion is the object code that is in the form of zeros and ones. So that is the compiler, interpreter, and assembler. Then we have another type of machine that is a virtual machine, and you can say that it is a type of software that is used to run, for example, it is a software based emulation of a hardware computer. Like for example, you may know about the virtual machine box or VM box. You are currently a Windows user, but at the same time you also want to learn Ubuntu, Linux, or any other operating system, but you have only one machine, and you want that on this specific machine or PC, my window should, if my window is already installed with window, I should be able to use Linux too. So for that purpose, virtual machine softwares are used. What they will do, they will create a virtual space for that other operating systems so that they can also operate there or you can also use them. Then we have the bytecode. Now, what is the bytecode? It is the intermediate code between the source code and the machine code. Like we have the class files in the Java. So if you have any information about the Java, so these are the, you can say that the class files, or you can say that the intermediate code between the source code and the machine code. So these are the basic computer or CPU architecture that contains the, you can say the control unit, arithmetic unit we have. We have the fetch execute cycle. Then we discuss the low level languages. Then after that, we discuss what is the translator, compiler, and the assembler. Now, here the thing is that now we are going to discuss is the basic logics. Means the logics or the algebra that is going to be used in computer science. In computer science, the algebra that is used is known as the Boolean algebra. Now, it is a branch of algebra or mathematics that deals with the two values, zeros and one. Ones will represent true in computer programs, and zero will represent false in computer programs. So, to deal with these zeros and ones, we have four types of gates or operations here. We have AND operation, we have OR operation, we have NOT operation, we have XOR operation. So what is AND? AND says that if the output will be true if the both inputs are true. And the OR operation says that only if one output is at least true, then the result will be true. So we will see all of these operators one by one. So first of all, to do the AND operation, we have the AND gate. So if you see this table is known as the truth table. So what is the condition of AND gate? AND gate or AND operation says that if the both conditions are true, then the answer will be true. If the both conditions are false, then the answers will be false, just like the multiplication. So if you multiply 1 with 0, what you will get? You will get 0. If you multiply 0 with 0, you are going to get 0. And if you multiply 1 with 1, then your answer is going to be 1. Like we have 4 inputs. We have 2 zeros, 2 ones. Then after that, we have 0, 1, 0, 1. When we are making the truth table, so this is the sequence. If you want to input 4 values, then in the first column, there should be 2 zeros, 2 ones, and then the sequence will be 0, 1, 0, 1. If you want to insert 8 values, then the sequence will be 4 zeros and 4 ones in the column A, and the 2 zeros to 1 in the column B. So this can be the sequence. This is how the input of the truth table is made. Now, if you see the condition of the AND operation is that if your first input is 0, your second input is 0, then your output is going to be 0. Your output will be true if they both are true. So I told you that 0 represents the false and 1 represents the true. So 0 means false, B means false. False, false, the output will be false. A is false, B is true. The answer is false because the AND condition says that if the both conditions are true, in that case, output is true. Otherwise, the output is going to be false. Now, if you see that it was false, it was true, the answer was false. It was true, it was false, the answer was false. Now, at the end, both are true. We have A that represents 1, that is true. B also have 1 that also represents true. And at the end, we have the answer that is true. So, A and B, true and true, will represents the true. After that, we have OR gate. Now, what is the condition of OR operation? If one output is true and the other one is false, then the output will also be true. Like it is denoted by the plus operator. Like if you add 0 plus 1, the answer will be 1. But it is false if the both conditions are false. Like if you add 0 plus 0, then your output in that case will be 0. Like here, 0 plus 0, answer is 0. False plus true, true. False, true plus false, then the answer is going to be true. Then at the end, both are true. So the answer is true. Like a light will turn on if either your switch is on. If your switch is off, the light will turn off. Okay, we are going to move forward. Then we have NOT gate. So what does the NOT gate will do? It will reverse the result. Like if input is true, it will result false. If the if the input is false, the result will be true. Like A is 0 means it will do the complement of your input. Means it will reverse the result. Like if it's false, it will turns out true. If it's true, it will turns out false. So that is the NOT gate. After the NOT gate, we have the XOR gate. So what is the output for the XOR gate? Means it is the combination of NOT and OR gate. So first of all, you are going to apply OR gate on it and then you take the complement of that. So let's discuss some examples of Boolean algebra. So let's suppose we have a security system. We have an alarm activity. So we have to give an output. So I say that if a door sensor or a window sensor is triggered, then what will be the logic? Means if A or B. To denote OR operator, we use this symbol. That is mentioned here. So to denote the OR operator, we use this symbol. To denote the AND operator, we use this symbol. And to denote the NOT operator, we commonly use this symbol. Okay. So these are the three symbols that are mostly used to represent the AND or exclusive NOT operator. Like I say that for light control, a light turns on if both room sensor detect the movement, A and B. If both detect the movement, then your detection will be A and B. Then the exclusive access means a door will unlock if one and only one person uses their key card. So what will be the logic? A and B. So this is the diagram for these tables. So this is the OR table, the truth table, and the diagram. Like we have the input symbol A, we have the input symbol B. I told you that you have to add A plus B. So input is 0 and 0. A plus 0, 0 plus 0, 0. Then 0 plus 1, 1. 1 plus 0, 1 and 1 plus 1. It will be 1 here. Don't try to add 2 here because in a computer, the computer only understands zeros and 1. Okay. The answer of 1 plus 1 is 1. The answer of 1 plus 1 then plus 1 will be 1. Okay, if you add too many zeros, then the answer will remains the same. It will be 1. Okay. So that is the OR gate. So after that, this is the diagram for the NOT gate. So see, we have an input symbol A. It will reverse the result. So if it's 0, the answer will be 1. So if it's 1, the answer will be 0. Okay. So that was the logical gates and the architecture of the CPU. How it is implemented, what are the methodologies behind them. Till now we have discussed the architecture of CPU and the different gates. Now what we have to discuss here is the control buses. So in CPU, we have the 3 buses that are used to manage the flow. Like for example, like if two persons have to communicate with each other, they must know a specific language, right? So uh, if let's suppose you are in another city and I am sitting in another city, let's suppose, and if I want to communicate, then I need a communication device like a smartphone or a PC or a system. Similarly, when the components of the computers wants to communicate with each other, let's suppose the hardware main memory wants to communicate with CPU wants to communicate with a hardware or hard disk to get some data from it, how they're going to communicate with each other. So for that purpose, buses are used. So what is the basic purpose of buses here? So buses are used to take for the purpose of communication. So that the different components like the hardware, secondary device, and this primary device can communicate with each other. For this purpose, the buses are used. We have the address bus, we have the data bus, we have the control bus. So what does the address bus will do? It will specifies the memory location, means at which location the data is going to be stored. Then we have the data bus that transfers the data between CPU and the main memory. Then we have the control bus. So that is used to send control signals to coordinate operations. Okay, so this is the architecture of the buses. So see, first we have this data bus, we have this address bus, and this is the control bus. So what is the purpose of data bus? The data bus will carry the data from different components. It will carry the data from CPU to ROM to RAM, and RAM to up to so on. Then we have the address bus. It will carry the address of the data from CPU to ROM, then to RAM to another unit. And what is the control bus? It will control all of these operations. Means if CPU and ROM wants to communicate with each other, so it will send signal to the data bus like this to send the data from CPU to ROM. It will dictate the data bus. So and it also dictate the address bus to give or send the address of this specific data to CPU and ROM because they want to communicate with each other. So these are the buses in computer system that are used to for the purpose of connection in the computer system so that the different systems can communicate with each other. Okay, so this is the concept of buses. And then after that, so this is another diagram that shows the working of buses. Like we have the CPU, memory, and input and output unit. So if these 3 components wants to communicate with each other, then for that purpose, buses are going to use, like the control bus, the address bus, and the data bus. So CPU will send a signal to the control bus that they want to fetch some data from the main memory. Okay, then this is how it will give. Now this control bus will give order to address bus and data bus to fetch the data and address for the main memory. So they will go in this direction. They will get the data, and this is how, in this flow, the data is fetched and managed from one part to another part. Then after that, we have the fetch execute cycle we have discussed. So for example, these are the user programs. The user wants to enter some data, like the ID, the what are the operations that the user have to perform. They want to do that. So they will give and call. They will fetch an IP. That address will be decoded. So fetch operation is performed. Then if you want to keep that data or not, if yes, it will go to execute all of these operations. Operations perform, then it will get back, get another operation, add, fetch that, take a decision, and execute that. This is how the CPU fetch execute cycle works. Like one after one, it will performs the operations. Okay. So after that, we discussed the high level and low level languages till now. So what are they? I told you that the language that is directly understand by the computer or the hardware is the low level language, and the languages that are not directly understand by the computer is the high level language, because these languages are directly understandable by the humans. So these are the high level languages and the low level language. So for example, we have the machine code, which means the instruction that are in the binary format. Then we have the assembly language, means the human readable mnemonics. So these are the high level and the low level languages. Okay. So we discuss the low level and high level languages. Then we discuss the translators, means the compiler. We discuss the interpreter. We discuss the assembler. So then we discuss what is virtual machine. We discuss what is bytecode. We discuss all of these things. So first of all, we had discussed what is the architecture of CPU. There are also other operations that are performed by CPU, like the arithmetic and logical unit of CPU is responsible for performing the arithmetic and logical operations. Then the control unit is responsible for managing or controlling the other operation. Then after that, we discuss the Boolean logical gates. We discuss the AND gate, we discuss the OR gate, we discuss the NOT gate. So then we discuss what is translator, we discuss compilers and interpreters, what is the need for them. We discuss what will be the flow control of that. So these are the basic architectures for the computer system. What will be the fetch execute cycle? I told you about that. Like if the CPU wants to execute something, then how it will be. So let me show you with a diagram how all of these operations are done at the end. So let's suppose, let me turn on the whiteboard for you. So like this will be the flow here. Let's suppose this is our CPU. So in the CPU, inside that we have the registers, because CPU, we have the fastest memory that are known as the register that are stored inside the CPU. So outside the CPU, we have the cache. I told you about the cache. Cache is also a storage medium that used to keep the most frequent data.